Anyway, all right, let's get started on this. All right, we're going to be talking about cross sections here, and cross sections are formed by just taking shapes again and not rotating them. We're just going to be taking shapes. So the first example I want us to do for a cross section here is to say that we want to take the region, and you probably want to write this down. Take the region that is
what is this called?
cross sections, volume using cross sections. Take the region bound by y. That'll make her dizzy to watch. Y equals x. X equals 2. And y equals 0. Find the volume formed by constructing isosceles triangles with the base perpendicular to the x-axis. Now, this is what I'm considering right here. I'm taking the line y equals x, which is right here. This is x equals 2, y equals 0. And what I'm doing is I'm making isosceles. Did I say isosceles right triangles?
No.
I should have. I put isosceles right triangles. All right. Now, essentially I've got a little small right triangle right here. And this triangle is actually coming out at you. It's three-dimensional. So it's coming out at you. And then here's a bigger isosceles right triangle. And it's still coming out at you. And then finally we have at the end, we got some really big right triangles that are coming out at you. And I constructed this to kind of help you see. That's y equals x, and then I have, these are the triangles coming out at you. Just pretend that it's solid, that there aren't the gaps in between them.
Oh, gotcha. So it's like the circles kind of.
Say that again?
So it's kind of like the circles.
It's exactly like the circles, except we're not doing any rotating. And because we're not going to be doing any rotating with this, we're not going to be talking about pi unless we're dealing with something like circles coming out at you. But we're not going to be rotating. Yes?
How long are those sides that come out?
They're the sides, since it's isosceles, the sides coming out at you are exactly the same length as the base right here. So if x is 1/2, then you're coming up 1/2 right here.
Wait.
Okay? So, I had this a lot pretty earlier today, and then I put a book on top of it. That doesn't do good for paper, especially when you're trying to make it stand up. So, this is the two-dimensional model of this? Well, it's going to form a solid. This is going to form a solid because we're going to have infinite triangles in here that are going to come out at you. And again, if we're talking about infinite sums, we're talking about, starts with an I. Sounds like integral. Yeah, we're talking about integrals. All right, so what are my lower and upper limits of integration here? 0 to 2. Now, again, I'm adding up the areas of a bunch of triangles. So it's going to be a lot of 1/2 base times heights, right?
Yeah.
Okay, well, I'm going to pull the 1/2 out front because it's a constant. Now, what is my base here?
The same as the height.
It's the same as the height. It's f of x, and since, what was this equation again for this line? Y equals x.
So it's x squared.
So it's going to be 1/2 of x times x. I'm going to do that in just a second. Dx. 1/2 base times height, isosceles, so the base and height are the same. So it's 1/2 of the integral from 0 to 2 of x squared dx. Alright, from there, let's just solve it out. It'll be 1/2 of x what? X cubed over 3. 1/2 of x cubed over 3 from 0 to 2. So that's going to be 1/2 of 8/3, which would be 4/3 maybe? 8/6, yeah. Okay, I'm with you now. I just had in my head 4/3 and that's what I was listening for. But yeah, you were right. And you get credit for it. Simplifying it, if you messed up simplifying it, then you'd lose credit for it. Of course, this wouldn't be a free response question. This would be a multiple choice question. Are we okay with this? All right. Now, the shapes don't always have to be triangles. That's going to be